We are used to AI as a reactive tool. You ask a question and a chatbot generates an answer. But the technology has moved on. We are now building AI agents designed to be proactive, systems that actually execute complex, multi-step enterprise tasks in the real world. The engine inside these agents is a large language model, and while an LLM has incredible reasoning capabilities and vast general knowledge, it has a massive blind spot. It doesn't possess the specific procedural knowledge of how your exact company gets its work done. Imagine asking an agent to generate a 47-step financial compliance report. Because the LLM doesn't natively know your internal workflow, you either have to manually prompt it through every single step, or worse, the agent has to guess what comes next. When an autonomous system guesses inside an enterprise environment, the results are severe. AI hallucinations masquerading as facts, compounding technical debt, and errors written directly into databases. To make an autonomous system actually useful, a smart reasoning engine isn't enough. We need a standardized way to teach these agents the precise operating procedures of a business. That standardized method is called an agent skill. This is a physical markdown file called skill.md. At the top, you have a lightweight section called the YAML front matter, which holds the skill's name and description. Below that is a massive body section containing the explicit step-by-step logic required to complete the job. If an agent had to load hundreds of these complete skill files every time it booted up, it would immediately overwhelm its memory, what we call the token budget. Instead, the agent relies on progressive disclosure. The system first scans only the lightweight triggers, the name and description, to figure out its available options. When a user's request matches one of those descriptions, the agent then pulls the heavy, step-by-step instruction body specifically for that isolated task. This mechanism allows the system to selectively retrieve intensive procedural instructions only at the exact point of need, keeping the agent's memory clear for actual problem-solving. These standardized files function as an agent's procedural memory. They offer a highly scalable way to teach a system complex enterprise tasks without breaking its technical limits. This diagram maps out an integration architecture, with Treecapital's Anven large language models sitting right at the center. Anven acts as the reasoning engine for the entire ecosystem, heavily optimized to prioritize 95% deterministic accuracy over open-ended creativity. Looking at this application integration pipeline, we can see how the reasoning engine gets facts. The Retrieval Augmented Generation, or RAG, pipeline pulls specific context from a vector database and injects it straight into the Anven inference step, grounding the model in your private enterprise data. But to actually do work, the agent needs hands. It uses the Model Context Protocol, or MCP. This acts as a standardized interface, allowing the central reasoning hub to securely reach out, pass through verification gates, and operate external software tools and databases. The agent's skills act as the instruction manual, coordinating all of this. They tell the reasoning engine exactly when it needs to retrieve facts from the RAG pipeline and precisely when it should trigger an action through the MCP. True enterprise autonomy requires this entire composable stack, where reasoning, facts, tools, and procedures are orchestrated into a single, unified system. As these workflows scale, Anven operates in a hierarchical structure. It acts as a high-level manager, taking massive, complex goals, breaking them down into discrete steps, and delegating those tasks to specialized, low-level agents built for narrow execution. Granting a multi-agent system autonomous access to live enterprise infrastructure and proprietary data carries massive operational risk. Left entirely unchecked, a flawlessly executed sequence could still make a disastrous business decision. That is why this architecture requires a human in the loop. The system drafts a comprehensive execution plan and then intentionally pauses. Before it executes any high-risk, non-negotiable step, a human supervisor must review the logic and explicitly approve the action. By combining the rigid procedural memory of agent skills with the secure human-in-the-loop architecture of Treecapital's sovereign Anven AI, we solve the autonomy problem. Businesses can transform artificial intelligence from an unpredictable experiment into a reliable, accountable enterprise workforce.